you for participating today. The AIA Monterey Bay Committee on the Environment is pleased to bring you our last talk of our 2021 series on green specifications. This talk is focused on Division 5, mass timber. This webinar qualifies for 1.25 HSUs and will be reported by our AIA-NB staff. This lecture is being recorded and will be placed on the AIA-NB website under the Clt tab. I've also placed a link in the chat for you to access those videos. Around 1 p.m., we'll open the floor to questions. You may enter a question in the Q&A box or raise your hand to ask a question live. We encourage you to ask questions and to engage with our speakers. Oops. I'm really excited today about our panelists. All are exceptional leaders in the world of mass timber who will speak to their knowledge of these wood systems. I've asked them to focus on the residential and small scale commercial sector, but also on its sustainability and safety benefits. Our hope with this series is that we can write more robust specs that specify low emitting materials, low carbon materials, durable without harm to the environment, and energy and resource conscious. Our previous lecture on green specs with Ann Hicks Harney gave an amazing overview on how we should approach our specs and listed many resources to assist us. Again, the link in the chat will take you to that talk. Today, our panel includes Chelsea Drennick. Chelsea is a licensed structural engineer in the state of California. She received her bachelor's in science from Harvey Mudd College and a master's from Stanford. Chelsea spent 9 years in structural design consulting prior to joining Woodworks. Her experience is in a variety of sectors, including residential, higher education, and retrofit of existing and historic structures. She is passionate about sustainability and the use of wood as a building material to reduce the embodied carbon emissions of structures. Megan Stringer is an associate principal with Holmes. As the firm's in-house sustainability expert, Megan brings a keen eye for reducing a structure's embodied carbon and use of unnecessary materials. Megan is the current vice president of the Structural Engineers Association of Northern California and is well-versed in working with large design teams, having led structural design for the largest mass timber project in North America, amassing 350,000 square feet of cross-laminated timber. And we'll learn more about that project in a bit. Jennifer Siegel is an associate professor in the School of Architecture at USC and the founder and principal of the Los Angeles-based firm Office of Mobile Design. Since its establishment in 1998, OMD has been recognized internationally with over 100 publications and awards for the fearless pioneering research and development of prefabricated construction systems. Jennifer is Chief Design Officer and partner of Wildernests. Launching in 2021, the company is described as the Tesla of real estate for disrupting the real estate industry and spearheading the sector's transition from carbon intense to carbon negative. Jennifer is the author and subject of several books, which I'll put in the chat window. As principal and CEO of Holmes US, Bevan is driving a path forward for modern wood construction. His involvement in the ICC Ad Hoc Committee on Tall Wood Buildings provides him with valuable insight into the regulatory process for adoption of mass timber, specifically cross-laminated timber, under various model codes adopted throughout the US. Bevan Jones has been working with owners and project teams and crafting fire engineering designs which keep the architectural intent while finding solutions to difficult code requirements, including egress, fire separation. And finally, we have Parissa Nasiri. She is a fire engineer with Holmes. Parissa has developed a diverse portfolio of projects. A large majority of her work has been on larger mass timber corporate campuses, giving Parissa a holistic understanding of the nuanced code and design strategies that make a successful mass timber structure. Additionally, Parissa applies her strong knowledge of local and international building codes to facilitate the approval of more sustainable tall timber construction. I also want to add that we have Jennifer's architecture studio here on this webinar, as this will be part of their curriculum. So we welcome all of you and thank you for being here. Fielding questions, we have our member Matthew Kyler, a local engineer who's passionate about CLT. Here we have our learning objectives. And before we get started, I'm going to launch a poll just to see about everyone's familiarity with mass timber and cross-laminated timber. And I'm going to launch this poll. And if you can just answer the first question, and then I'll launch the second question at the end. So just answer the first one, and then I'll publish the results.
It says we can't vote, Libby.
Okay.
Do you want us to do it in the chat?
It's just for the hosts. We can't vote, Jennifer. I think the audience can.
Yeah, host and panelists can't vote.
I like
No one's voted yet.
Hopefully we know about it, yeah.
Okay, let's see. I'm not, okay, 0 of 26 have participated. Maybe put in the chat, are people seeing the poll?
Participants can't vote.
Okay.
The poll has an error.
All right, well.
Let me see if I can do something here for you.
Okay. Otherwise, we can just have it pop up at any point. But the first question is, have you heard of cross-laminated timber? So I now would like to open up our first slide I'm going to leave the chat. And I'm going to open up the floor to Chelsea now.
Great, thank you. All right, let me start this. All right, can you see my screen okay?
Yes.
Excellent, thank you. So, hello everyone, thank you for coming and thank you for having me. I'm Chelsea Drenick, Woodworks Regional Director for Northern California, Nevada, and Utah. And today we'll be discussing mass timber construction, products, performance, and design. So quick word about Woodworks, what we do before I jump into my presentation. Woodworks is a nonprofit organization dedicated to helping project teams design and construct wood buildings. So we do a lot of presentations like this, and I do lunch and learns for offices. All our presentations are AIA accredited, so if you're interested in that, please reach out. We also do free wood design assistance to architects, engineers, and others in the building industry. Our goal is to help make wood buildings successful. So as Libby said, I'm Chelsea Drenick. I'm the main point of contact if you're in Northern California. My colleague Mike is in Southern California if you're located there. We provide assistance based on where designers are located so that we get to know local codes and get to know designers in our regions. So reach out if you have any questions, and I'll put my email in the chat once I'm done with this. Because we're talking about mass timber, I just wanted to share with you the Woodworks Innovation Network. Our project assistance is confidential, but we wanted something that would allow folks to showcase their projects and connect with other experienced professionals. We're also tracking projects, mass timber projects we know of in design and construction at over 1,000 here in the US since we started tracking in 2013. So really exciting to see. So I'm going to do a quick mass timber overview before turning it over to Holmes, looking at what products, mass timber products are, and a few brief design considerations. So mass timber construction. I like to think of the delineation between mass timber and heavy timber. Where heavy timber construction, we're thinking of a solid wood member, a solid 8x8 piece of wood for a column, solid 10x14 beam. Mass timber can have these same sizes, but it's made up of a number of smaller pieces that are laminated together either using adhesives, nails, screws, or another type of mechanical fastening. So here's a visual comparison I like a lot. Mass timber on the right, heavy timber on the left. So one of the old adages with heavy timber, this historic construction, was large column, large tree, meaning that every single large piece of wood needed to come from a single tree, which can be really hard to source. So if you have to have that 12 by 12 column, you have to have a tree that's larger than that. So on the right with mass timber, we can still have that 12 by 12 column, but instead of coming from one singular log, we can make it from smaller pieces. We can use commodity lumber products, perhaps even lower grade products using smaller diameter trees to still produce these large size elements, these columns, beams, panels. So mass timber buildings, we have a lot of different options for design. I think most common is post and beam, which is shown on the left. Common for office buildings, post and beam are typically glue lam, but they could be solid sawn, LVL, or another type of engineered wood product. Flat plate CLT here, shown in the center where we're using CLT as a two-way span, similar to flat plate concrete construction. So looking down this photo, you see there's no beams, only CLT and posts. So we do have a tighter grid spacing here. So we have seen it more commonly used for residential. I think the grid spacing shown here is 9 by 13. It's a photo here of Brock Commons, a student housing project in Canada. On the right is honeycomb, more common in Europe. Honeycomb or house of cards style construction, where both the vertical bearing systems, those walls, and the horizontal decks, or floors and roofs, are all mass timber. And the thing with mass timber is we don't have to have an entirely mass timber building. We've seen for multifamily or residential, CLT floors with prefab panelized light frame wood walls used very successfully. That's shown on the left. Basically replacing those floor joists, usually TJIs, with CLT panels that span to the wood bearing walls. On the right, we also can do a steel hybrid. Maybe this is the best fit for your project. Seen this on a lot of office projects, and I think Holmes will be showing us some photos of this later on. All right, so of those 4 framing styles, we saw a number of products and introduced those briefly as well. Glue laminated timber, glue lam, are posts and beams typically of these buildings. Very simply, 2x glued together, then planed down. It's been around for 100 years. We use it in light frame construction for those longer spans. It can be hidden in a wall, then we have an industrial grade typically, or it's exposed in an architectural grade. So very common, as I said, for the posts and beams. Nail laminated timber, NLT. So this is a combination of 2x members, usually 2x4s, 2x6, 2x8, oriented on their narrow face. So the strong axis is in the downward direction. Multiple laminations laid up side by side. Each lamination is nailed to the previous. So we're usually using these for horizontal applications, the floors, the roofs, and we're always going to be adding plywood or OSB to the top face so we can have that in-plane shear capacity. NLT is really something that's interesting because it can be prefabricated offsite or it can be built on site. It's been in the code for a long time as mechanically laminated decking, very prescriptive. And it's very different than other mass timber products that are always prefabricated by a manufacturer. So NLT was more popular when mass timber supply chain was less mature. Now there's a number of CLT suppliers across the country and across North America and Europe. So for larger projects, it's much more cost effective to use a prefabricated panel. However, on smaller residential projects, or if you have a feature room where you really want to showcase a panel like this, it can be a good solution. One thing to consider with NLT is that since all the grain is running in one direction, need to account for shrinking and swelling as moisture content varies during construction. So that's why shown here in the photo on the bottom right, you're basically leaving out a lamination so that that movement can occur during construction without causing any damages. So you can fill that in once the project's complete, which is different than CLT, which is dimensionally stable, and I'll talk about that in a moment. All right, so I wanted to include this here, the nail laminated timber design guide, free from Think Wood. I can put a link to this in the chat as well. If you're interested in nail laminated timber, it's a great guide that goes through design considerations, and it also has an example specification at the end. Dowel laminated timber, DLT, very similar to NLT in terms of members that make it up. 2x, vertically oriented. Difference here is instead of nails, we're using hardwood dowels to mechanically fasten these laminations together. So no glue, no nails, just wood. There is one dedicated DLT manufacturer in North America, and that is StructureCraft. This is not something that can be easily built on site. All right, so here's the product everyone's probably heard of, cross-laminated timber CLT. Kind of in the spotlight here, number of manufacturers here in North America and in Europe that can manufacture to the required PRG 320 standard that's required by code to use CLT. And I think it's kind of interesting because I think CLT is kind of used interchangeably with mass timber, like we talk about CLT buildings, but it is actually a product. A cool thing too is there's now CLT with structural composite lumber laminations. This is a product from Freris Lumber up in Oregon called Mass Plywood Panel, MPP for short. So basically really big plywood, layers of plywood glued together to make these large plates. And they can also cut it and make beams and columns out of it as well. So different finish, still CLT per code. Here's a quick project example of a Clt hybrid building with the structural composite lumber laminations, the product MPP. Hybrid light frame wood walls that were panelized with these MPP floor plates and roof plates. 4 stories in Oakland, very tight urban site, as you can see. There was no room for staging. And that's part of the reason the contractor chose, they decided to switch to these MPP because the walls were panelized, the floor was MPP. So all the trucks, everything was trucked in and lifted into place right from the truck. So the contractor said originally it was designed with a light frame for the floors, TGI joists. The schedule was 14 months. When they switched to MPP, it was cut down to a 10-month window. And the contractor, Scott with Gurnett Point, has talked about this project a lot, and there's some great webinars online if you'd like to learn more about it. All right, so back to our typical CLT with solid sawn pieces. So CLT is typically formed taking 2x side by side. We lay those down, put some adhesive down, and then the next layer is cross. So 90 degrees oriented to the first, and then so on and so forth, usually odd number of plies, 3 ply, 5 ply, 7 ply. And the reason for that is these outer plies are running the long direction, strength axis, and the other direction is the minor or weak axis. So we do have strength in 2 directions, unlike NLT and DLT. So that's how we can have that flat floor plate construction that I showed earlier. But in one direction, you're always going to have a shorter span than the other. All right, so I have a cool video here to show you how CLT is made. So we're starting with a commodity lumber product. This is 2x. And the first thing they're going to do is finger joint them end on end. So then we can have these longer panels that are typically 40 to 60 feet long. So we take these longer pieces, cut them to size. Each CLT panel is made for a specific location on a specific project. So here they're putting those plies into there, then we get the adhesive on, second layer. So here there's a diaphragm opening, probably some MEP penetration. You can see the specific size of the panel for a specific location. Then it gets pressed and then goes through the planer. So here we're going to have a 3-ply panel. So noted panels are about 8 to 12 feet wide, 40 to 60 feet long, and that's dependent on the manufacturer. Each manufacturer has different size press. So it's important to engage with manufacturers early on if possible. If not, make sure there's room for adjustment once a manufacturer is selected. So a few project examples here. This is a cool local project here in the Bay Area, Cooley Landing Center. It's in Palo Alto. They have exhibits on natural history and including 2 exhibits on endangered species, provides meeting space and learning facilities for the community, as well as a venue for celebration. So you can see the CLT in the roof. Here's an office building in Portland, Oregon, Albina Yard, 4-story CLT and glulam frame structure. So unlike NLT and DLT, where we need that expansion joint between the panels, CLT is very dimensionally stable due to those cross laminations. So you don't need a joint there between panels. Another local project here in San Francisco, I believe it's very close to open, which is cool. 4-story office building, 3 stories of mass timber, or 1-story concrete podium. I like to show this one because the reason they went with mass timber, one of the main reasons, was significant cost on foundations, or significant savings on foundation costs. And that's because they were looking at a concrete or a mass timber building. Mass timber is much lighter weight, so they were able to reduce their piles by, I think, 50%. So very cool and a good option for poor soil sites. All right, so talking about connections. Connections are going to include a lot of these small diameter self-tapping screws, and we're going to see proprietary or custom fabricated beam and column hardware, kind of a new vocabulary of connections. Lots of different shapes and sizes for these timber self-tapping screws. I was on a project site recently, and I think they had like 40 different sizes of screws, a bit too many, I think, but it's kind of amazing, all the different screws that are used. Also, there's an ever-improving market of tools to install these longer fasteners easier and more accurately. Just touching a little more on connections, I mentioned that post and beam is a very common form of construction, and I just like these photos because it shows 3 different ways to accomplish this. You know, on the left, fabricated steel plate, bearing connection here, designed by the structural engineer, fabricated in a steel shop. In the center, we have proprietary hangers. And on the right, it's a very simple connection. You know, we're still accomplishing the same thing, but the beam slotted into the column. So a lot of different ways to accomplish the same thing. And things to think about are shrinkage. You know, think about that beam shrinkage. We don't want it to accumulate over the height of the building. And also fire design of connections, which we have a lot of experts here from Homes to talk about as well. Lateral systems, code process turns slowly. So working on getting Clt shear walls into the code, and there are design provisions, but there's no R value yet. So we're almost there. There are some projects using it, using Clt shear walls, you know, depending on an open-minded jurisdiction and a performance-based design, seeing them on some smaller projects. But typically, for larger buildings, for office buildings, we're seeing steel or concrete used. One thing to consider with these is flexibility in the detailing for tolerance difference between the materials. Or for residential, smaller projects, light frame shear walls, our typical wood shear wall design works great as well. All right, connecting these panels together. So on the left, you can see there's plywood on top. I believe this is NLT project shown. So we need that in-plane shear capacity from the plywood itself. So if the plywood's installed in a factory, it'll be left shy of the edge of the panel. And then you'll use this plywood spline to connect the 2 panels together. If weather is expected, it's important to tape that joint so that the water doesn't get through and stain your CLT underneath. The exciting thing is for CLT, recently released code, the SPIDWIZ special design provision for wind and seismic, the 2021 version, does have provisions for using the CLT as a diaphragm for seismic loading. So we're still going to have a surface spline here, plywood spline connecting the panels. That's not adopted by the CBC yet, but we are seeing a lot of jurisdictions allow this approach. All right, acoustics. So lightweightness of CLT panels. It works for us for structural design, you know, more efficient seismic systems. And the construction of the building, lighter weight, smaller foundations, works against us for acoustics. So we won't just have a bare CLT panel. So typically we're exposing the ceiling and then we have finish on top. Part of the reason for that too is it's a softwood product. CLT. You don't want to leave that top surface exposed. As soon as someone starts wheeling a chair over it or walking across it with boots, it's going to be damaged. You know, it's a strong material, but it's not super durable for that. So typically what we're seeing used is an acoustic mat put on the CLT, and then concrete gypcrete, 1.5 to 3 inches. That could be the finished surface. You can polish it. Although it's tricky if you want to, meet a high rating STC, IIC, you're going to need a decent amount of concrete there unless you put a finished floor on it. And if you want to omit the concrete, there are options. There's proprietary Acoustimat products that have been tested. We actually have an inventory of tested assemblies, acoustically tested assemblies on our website. So that is helpful when you're starting out if you're looking for that for a multifamily project. All right, I'm just going to briefly introduce fire design here because I know there are some experts here that can talk about this at length. So this is certainly a subject of much discussion and conversation when we're talking about exposing mass timber. People want to know, how is that going to perform in the event of a fire? Well, wood, as it burns, heavy timber, mass timber in particular, it burns at a rate that we can predict very accurately, and it burns fairly slowly. As it burns, it's forming this char layer on the outside of the exposed surfaces that's insulating the wood. That char layer is keeping that inner wood cold so it can retain its structural properties. So there's been significant testing here. We can very accurately predict at what rate this char layer will form so that we know how much wood is left given a 1 hour, 2 hour rating. So that's approximately 1.5 inches per hour, but you will need a structural engineer to calculate that. So there are tested assemblies available, mainly for some connections as well as CLT floors. But calculations are also permitted to do in lieu of a tested assembly. And for larger projects, a more rigorous fire analysis is typically done. And I'm excited to hear homes talk about that. All right, so that's kind of a context for what projects will look like, what the products are. And I kind of just wanted to touch on why we want to use mass timber. What are the benefits here? All right, so our global population is increasing. Where do we house everyone? Where will they work? How will climate change impact where people can live and work? So we need more buildings. We need more housing. We know that here in California for sure. But buildings generate nearly 40% of annual global greenhouse gas emissions. That's what we're seeing in the yellow pieces of this pie here. 28% is building operations, 11% is embodied carbon emissions. And embodied carbon emissions, that's when a building is built. How much CO2 is released due to its materials and construction. So diving into this a little deeper, embodied carbon, operational carbon. Operational carbon is a bigger portion of building emissions, but embodied carbon is an upfront cost. For this building here, it takes 17 years for operational carbons to surpass embodied carbons. So we can have a real impact by reducing them in the short term. And these percentages do vary from building to building. This example here is a traditional non-wood building. So I think the building industry has focused a lot on operational carbons, which is great. We need to reduce those. But now we're looking at these embodied carbons more and more. How can we reduce them? Operational emissions are only improving with greener grids, more efficient heating and cooling. Embodied energy is not insignificant, and it doesn't have to be this necessary evil of building a new building. So one thing that can help with that is wood. Wood is 49% carbon by mass or weight. In other words, approximately 50% of this wood is carbon that was in our atmosphere, contributing to global warming. It's now physically converted into a solid form of wood and put into the building. Whole building life cycle assessments typically show wood buildings as a way to reduce embodied carbon footprint of a building. So this is a long and complicated discussion too. And I actually did a talk yesterday at AIA California on wood and carbon and some vocabulary around that. So if you're interested in more, that will be posted shortly to AIA California website. But for the time, we'll move on to the next why mass timber. This idea of biophilia. There's an innate human instinct to connect with nature. We feel good around wood. Studies have shown it, in office buildings that are made out of wood, there's higher retention, people are happier. And just looking at these renderings, which one would you like to have as your living room? Construction impacts. We know labor availability is a challenge right now in the construction industry. Mass timber is a way to integrate off-site construction. Then the crew on-site could be smaller, and we're creating more jobs offsite in a more safe work environment. And this point is tied to the previous. Compressing construction schedules will reduce the requirements of labor on site, requiring less time of folks on site. Time is money. Mass timber helps with this. It requires a lot of coordination up front, but then when it gets to site, it's like a set of Legos or IKEA furniture. It goes up very quickly. So this is a project feasibility study that was done for a 12-story tower in Seattle. It's a published study that you can find online that compared a concrete construction schedule to a mass timber construction schedule. And they determined there was a 5-month saving on the construction schedule to use mass timber. Developers like to hear that. Time is money. They'll see the returns that much faster. All right, so those are sort of the market drivers that we see for mass timber. I talked about construction efficiency and speed, construction site constraints for infill or urban infill projects. I mentioned Project 1 in Oakland, how they could install things directly from the truck. Secondary drivers, I think, depending on the projects, these secondary drivers could be primary drivers, carbon reductions, structural performance, lightweightness, especially important for poor soil sites. And we have some checklists, mass timber design and cost optimization checklists on our website. On the 3rd page is a summary table of benefits of mass timber. I'm not here to say mass timber is right for every project, but if some of the benefits ring true, it might be worth exploring. Go over that with your clients. All right, so where is mass timber going, particularly here in California? And that is taller. So prior to the 2021 International Building Code, IBC, wood buildings, either light frame or heavy and mass timber buildings, were limited to 5 to 6 stories based on occupancy. So 5 stories for residential, 6 stories for business. And so we know that Europe kind of started this tall wood movement. So to catch up, a tall wood ad hoc committee was created here in the States to explore and push forward new code provisions. And what they did is do 5 full-scale mass timber fire tests in a multi-story apartment building that were conducted in summer of 2017. And the key to these tests that they wanted to prove was that they could get burnout of a fire without collapse. So I mentioned charring earlier, how it protects the integrity of the wood. That's what these tests prove, that the contents of these apartment buildings could burn, the mass timber chars, and the structure remains standing, that these fires go out on their own. So given the success of these tests, the ad hoc committee proposed 17 revisions to the 2021 IBC to include new tall wood construction types, and those were all passed and included in the 2021 IBC. The California Building Code, the CBC, has an intervening code cycle where additions are made to the current code. And so they adopted these provisions early. They were passed unanimously on August 13th, 2020. And they were published January 1st of this year, and they became effective July 1st. So there are project teams across the state already working on design of projects using these new provisions. And one of the big proponents, I think this is really cool, of these new provisions was our state fire marshal, Chief Mike Richwine. And he said there are 3 main reasons that it's important to adopt these early. Has the potential to increase the market demand for mass timber production in California, bringing new jobs to our state. Increase the pace and scale of our wildland fire prevention and forest management goals. I mentioned earlier that mass timber is made up of smaller pieces, that we can use these smaller diameter trees. So it's incentive, if we can bring mass timber manufacturing here to California, and there are many people at the state level working on this, it's an incentive to thin the forest of those small diameter trees to help with fire prevention. And his 3rd point is mass timber construction can also help reduce the carbon footprint of buildings. As we get into these taller buildings, we're reducing the number of concrete and steel, new concrete and steel buildings. So these are the new provisions, and I think Holmes is talking about this more. So I just wanted to introduce these, the types. Type 4A goes up to 18 stories, kind of based on Brock Commons, which was the 18-story student residence hall in British Columbia. For Type 4A, all the wood must be covered with non-combustible protection. type 4B goes up to 12 stories, somewhat based on this project in Portland that hasn't actually been built framework. Some of the wood, mass timber, can be exposed. Type 4C allowed up to 9 stories for business occupancy, 8 stories residential. And this is the Carbon 12 project that is in Portland. And it's also up to 85 feet in height. All the mass timber can be exposed. All right, some last notes here. I just want to highlight some Woodworks resources. If you are looking to design a mass timber building, we recently released this index of mass timber connections, example connections on different ways to design, both structural and architectural detailing, available for free on our website. And also, if you're working with a contractor that hasn't installed mass timber and is nervous about it, we have been providing mass timber mock-ups to carpenter union training centers around the country. And excitingly enough, there is a new one in production right now that's going to go to Buena Park, California, which is very near Anaheim. So any contractors, carpenters that are union can go and go to these training centers and learn how to install mass timber. So more information on our website if you'd like to connect to anyone with that. And with that, I will turn it over to Holmes.
Thanks, Chelsea.
That was great.
All right, let me get the screen up, and then I'm actually going to turn it right over to Parisa. And I guess note, we did get a question on construction type in the chat. I don't know if you've seen that, Parisa, but you could probably address that when you get started. So
yeah,
I think we're
good. Cool. Thanks. So for the next about 20 minutes, we're going to cover how we can achieve the mass timber construction, what are the lessons learned that we had, and a few case studies that we're going to cover at the end. So from exactly what Chelsea mentioned, up until July this year, the maximum number of stories in height that we could go for the mass timber construction was 6 stories in height for office building, 85 feet in total building height. With the new construction types, we were allowed to go from 9 to 18 stories in building height, for 4C, 4B, and 4A, with limitations that comes with them, for the amount of exposed mass timber that we can have and the extent of non-combustible protection that we need to have on the mass timber elements. And with that, going to the next slide, the total, all the construction types that we can use to have the mass timber construction would be 4A, actually 4A, 4B, 4C, for heavy timber, and both 3A and 3A, 3B, and type 5 construction type, both A and B. We had a question about whether we can use a mass timber in a type 3 construction. And the answer is yes, just because the code language basically says that for the interior building elements of a type 3 construction, we are allowed to use any material that is permitted by the code. With that, noting that the exterior walls of type 3 construction are not allowed to be mass timber. So the exterior walls for type 3 and type 4 heavy timber construction need to be non-combustible material. But the new code provisions for 4A through 4C does allow mass timber for exterior walls, but with some limitations, has the exterior protection of the mass timber and at the same time, the interior protection depending on what construction type we're using. Going to the next slide. So these are the 3 new proposed construction types. 4A, which allows us to have 18 stories of office building, up to 270 feet in height. The building needs to be fully protected with non-combustible protection. So that would be but most likely gypboard protection directly attached to the mass timber to achieve 3-hour fire resistance rating for the primary elements that we have. The next construction type that we have is a 4B, which allows us to have 12 stories of 180 feet in height. This construction type allows us to have 20% of exposed mass timber on our ceilings. If we have, for example, a residential unit, that would be 20% of the ceiling within each dwelling unit. Or if we want to have exposed walls, that would be 40% of exposed walls in the unit. And then for the 4C, which is also a 2-hour rated construction type, we can have everything exposed, all of the beams, columns, and the ceiling can be exposed mass timber. With that, there has been, after the test that Chelsea mentioned for the compartment tests that were done, that as a result of that, we had these new construction types. There has been a series of new tests in the RISE Institute in Sweden, in collaboration with American Wood Council, which basically resulted in the new code proposals for the next cycle of the code. With that, the type 4B construction type is proposed to have up to 100% of exposed mass timber on the ceiling area. This code section has not been approved yet. It's still going through the process, but it's basically results of the test data that was conducted a few months back in the Sweden. And with that, I'm going to pass it to Megan.
Thanks, Bruce. I think right before you stop, I think we have a live audience question by Carrie.
Yes, thank you. I'm trying to visualize the mechanics of the fire when the wood chars and how the structural members are sized. So let's say I need a 6x10 header, and you're saying that like maybe the outer 1.5 to 3 inches might char in a fire to protect. So does this header still be sized? Is it still sized at 6x10, or is it 6x10 plus 1.5 on each side, so that after the char layer is formed, you still have 6x10 in the middle? And then also, what happens after the fire? Does the char get scraped off? I'm just kind of walking through the steps of what happens when the wood burns and what you're left with in terms of structure, what you do with it afterwards. And this goes to building resiliency, and how we move forward from there.
Hey, Kerry, this is Bevan with Homes. I can provide a little context or response to that question. It's simply put, let's say it's a column or your header beam in question. Essentially, you'll size that header for the structural demand required. So it's essentially its cross section is going to be, minimum cross section will be based upon what structural demand is required for that element. And then we essentially add on, essentially what we call a sacrificial layer or char layer to that element. So you're essentially upsizing it to provide the protective layer. So if it's 1 hour protection, it's going to be about 1.5 inches. 2 hours, you're still looking at, nearly 3 inches. So you're essentially just adding on the additional cross section of that element to account for the char performance.
Right. That was my concern, was that you end up with, especially for residential or smaller scale buildings, pretty fat members, because they all start to get oversized in anticipation of the char layer.
Yeah, they do. There is obviously, once we look at sort of fire load limit state case, there are some reduction factors in the structural design that you can account for. So your residual cross section that's left for the structural loading, there are some reduction factors that come into place. You do get to squeeze that column size down that's required for your minimum structural load a little bit. So, but in essence, you're essentially, this is what's required for the structural load, and we add on additional protection. But there are some nuances there in the code that allow you to sort of apply some reduction factors. So you do get some benefit there. And when we start to look at higher rise buildings, you'll tend to find that the column size or even element size becomes structurally governed. And so the fire ratings inherently incorporated into that section. To the second part of your question about the, if you, after a fire event and you do have a loss of section, obviously determine how much loss of section, is there enough that you still maintain the fire performance or fire protection to that section for structural load. And if not, it may warrant replacement of that element, or you may be able to sister on additional protection that might be, whether it's glue head or mechanically head, to again apply that cross section that's providing your char performance. And so what's important is obviously with any element, remove the char layer, plane it down to a surface that you can now adhere sacrificial layers to. And again, if you're looking at comparing that with the steel element or concrete element, all of those elements, again, impacted by fire. You have a steel beam that has fire wrap around it. That steel beam still is heated and will deflect and deform, which will likely require that element to replace after fire exposure. So even comparing against other construction types from a resiliency perspective, you have the benefit of either repairing or replacing a wood element.
I would like to also just note for small residential, if we're in type 5B, we're not going to need to provide the sacrificial later. It's only if you need that fire rating.
Correct.
But we have 1 hour ratings, even in 5B between conditioned and non-conditioned space and around certain areas. So there's still fire ratings regardless. It's not as extensive, but, and now, especially we're going to get more density on single family lots. We're going to, as of yesterday, more 2-unit, 4 to 4-unit buildings. Those you're going to get a lot more fire rating issues with those.
And I guess just to reiterate what Bevan was saying, it will depend on your structural load case, and a lot of times fire isn't the governing design on your element. So you could very well have your element size for, let's say, vibration, and it already is meeting the required fire layer. So it depends on case by case. But let's move on. So now we're just going to jump into some mass timber lessons learned that we've kind of just uncovered on a lot of the projects that we've been working on. So I think the biggest one, and Chelsea definitely touched on this, is around kind of grid and different manufacturers and capabilities. And so if we're looking at grids for mass timber, if we're talking about, any type of larger 30 by 30 grid, I know that's more in that optimum office range of what we see typically, easy to program around. When you get into grids like that, you are looking at a mass timber option that has kind of beams in both directions. So you're going to have joists in one direction that are going to pick up the CLT span that are then spanning 2 girders. With that, you can play around, kind of that image in the middle is just showing you can play around with how you're stacking your joists and how they're framing into your girders to allow for some cavities for MEP integration, which we will talk about shortly. Kind of another grid is where we're really trying to minimize the timber volume, is where you're looking at more of a one-way system where you just have beams in one direction. Those grids are typically more in the 15 by 30 range. That can vary. I think with any of these options, you can start to introduce other structural materials and kind of come up with these hybrid systems. So whether you're introducing steel or even concrete beams to help you span a bit further, there are some options there to allow for a bit more flexibility in your program. And then kind of the other grid, as Chelsea mentioned, is kind of that what I kind of usually refer to as a point supported option. So it's really just your CLT supported on columns only. So there's no beams. Again, you're going to be limited in your grid based on your panel dimension. And so typically manufacturers can fabricate a panel about 10 feet wide. So that is going to set your grid in that one direction. And then you can span a bit further in the orthogonal direction. But again, when you have this many columns, you're usually looking at more multifamily residential or residential options for this type of system. And then one kind of play on that is a system that's mainly been used in precast, but it has been used in mass timber, and we've used it on projects, is integrating in what they call a delta beam. And it is just kind of an upturned steel kind of like channel shape that you then cast concrete around, and it does allow you to open up your floor plans a bit and span a bit further and still have a relatively flat soffit. And so, as we mentioned, all of these mass timber products are pre-manufactured. And so knowing kind of the players that are in the game are going to be really important, because they all offer and have different capabilities. And this is just a map. It might even be outdated, Chelsea, so I might need to ping you to get the most up-to-date information, but just kind of showing where the mass timber suppliers are in North America, where they're coming soon. And then this is really just, if we're just looking regional, so regional to the West Coast, talking about how there are different suppliers and they offer different things. And so you can kind of just see here in the chart is that panels are typically, up 10 to 40 feet long, with a few manufacturers having capabilities to go higher than that. So understanding that when you are starting to lay out your grid for your projects is going to be really key to coming up with an efficient mass timber system. And the next kind of biggest lesson learned was kind of just around integration and a bunch of different types of integration here. And first up is really that MEP integration. I think we have found that the most successful mass timber projects and ones that are able to keep the mass timber through construction are ones that are integrating the MEP systems in with the floor system. And this is just a couple of ways that you can do it. There's a lot of different options even to this. These are just some common ones that we've seen where you can play around with that. I think we're also seeing is that MEP integration wants to happen way sooner in design than it typically does in typical projects, in that you want to get all of your openings and all of that coordinated so that it's getting fabricated into your panels in the shop. So some pictures of that, of options of that in construction. The two on the left are really just kind of illustrating that gapped CLT. So you really just leave a gap in between your CLT panels that does allow for your small surfaces to run over your beams. You do span that with plywood, so you are kind of limited to the spans there for how big that gap can be, but definitely a great option for integrating your services. And then the image on the right is showing a lot of the, these are electrical boxes that are going to be in the floor that they would get cast into a concrete topping slab. So that kind of hides a lot of that within that slab. The next integration is really all about project team integration. And I think you'll see with these mass timber projects, there's a lot of different players that are on board that are really helpful in kind of the iteration of for this example, detailing. So this is really just showing the structural beam to column detail for a project, which we'll talk about in the case studies of where this was going to be replicated many times, and we needed to put the column in bearing. And so you're kind of seeing that first sketch with the architect on the left and kind of how that details had been refined throughout the process, and whether that was more feedback from the architect, general contractor, and even the manufacturer, and what their capabilities are in terms of fabricating these types of detailing. And then with that, I think is the structure fire integration that we've been talking about. But I think Bevan, did you want to speak a couple words just on this?
Yeah, sure, Megan. Thanks. Just back at you on the what you just mentioned. I think particularly with this sort of design, particularly as we're looking at the advantages of mass timber, the sort of kit of parts process of components, shipped to site and manufactured on site, sort of like a Lego set, as Chelsea mentioned. Being able to see the benefits of speed of erection and using a lot less labor force on site. The devil's in the details really, and sort of working through a lot of these details at the front of the design. So sort of back to that point of project team integration, it's really important that there's a lot of consultant scopes worked through at the start of the design, particularly with regards to the structural design, fire, the acoustics, the MEP integration, etc. It's important that a lot of these aspects are worked through. And the other aspect is that, unlike sort of a lot of conventional construction types within the industry, we've had many years of development, testing, etc., and a lot of UL listings and libraries to call upon for various products and ways of doing connections design. Mass timber unfortunately doesn't have that, but it is happening very quickly. And so part of this is really developing details that might be penetrations, edge of slab, head of wall, penetrations through details, and really sort of fire protection of your connection details. So it's important that sort of work through those during the design phase, and Woodworks is a great resource for a lot of detail on acoustics, fire ratings, and floor assemblies, etc. So really take the time to look up the resources that they can share. So focusing more on the fire side of things in terms of the structural integration, There's been some recent additions to the code language around protection of connections. It's been fairly silent in the past, even in conventional steel or concrete industry as well, in terms of protection of connections. But with regards to wood, we typically use a lot of steel connectors, and it's important to understand the performance of those steel connectors when exposed to fire, and also how we're protecting those connection details for these mass timber buildings to maintain their structural performance in fire event. So there are some simple calculations that can be done that are referenced within the California Building Code as an example, which will refer you to the National Design Specification, where Chapter 16 outlays calculations for fire resistance of mass timber elements. Part of this is quite often because we don't have this sort of years and years of research and development and testing, a lot of the connection details are fairly ad hoc. As a part of this is where we have complex details, we have this opportunity to use performance-based design to validate the performance of those connection details in fire. So understanding where we may need to protect pins or bolt connections, with dowels or intumescent coatings, where we may get concrete, etc., providing protection, and where we can utilize embedment of those details, essentially concealing those details within the mass timber elements and using the mass timber as a protection to those steel elements. It really starts to simplify this Lego set or kit of parts process and starts to create those efficiencies on site. It really avoids the need to have contractors come through afterwards applying fireproofing and instrument coatings, is to really start to slow down that time frame. And part of this is, and again, getting back to this integration of services, we can see on the left an example of a energy dissipation system, and then incorporating a block at the bottom of that Clt plate design to provide wood protection to an embedded steel design, and really looking at the details of these assemblies, how they go together. And then if need be, you can either do fine-tune analysis to justify that they work, or do full-blown fine-tune testing to validate these performance. And the example you see there, I think, is testing from the framework project, which Chelsea mentioned in the past, which has been a great resource for, particularly as we go to high-rise buildings and performance of these mass timber elements to 2 or 3 hour fires. I'm going to now pass on to Parisa, I believe. Oh, sorry, Megan, to go through some case studies.
Yeah, I think we'll skip over this. This is just talking about different lateral systems that we've been seeing in these buildings, with Chelsea kind of already touched on. I think when you're starting to push the spans of a mass timber system, you do, in certain cases, need to pay attention to vibration. And so being able to work with your engineers to develop your vibration models and figure out if you're trying to target a higher vibration criteria, that we can achieve that for you. We within Homes have kind of built a timber optimizer tool that we have found really helpful to be able to iterate between all these different design constraints that we've been talking about today, with like fire rating, span, height, and all of that, and be able to really iterate quickly between different options. So we'd definitely be happy to share with you some of that. This was just going through a quick case study, and again, we'll share these slides with you so you can kind of read it. But it is kind of just looking at a different grid options for a laboratory building, and kind of seeing the differences in wood volume as you kind of play around with the grid. And so we see volume as really the link to cost. And so, the more volume you have on these projects, the higher the cost is. And so with that, yeah, we've just been seeing lots of different unique solutions for these projects depending on the project drivers. And it's been kind of fun as an engineer to be able to, come up with these different solutions, but just noting that we really haven't been seeing that kind of one size fits all. I think this is kind of back to you, Bevan, to just go over some rough example or project examples.
I think Chelsea covered a lot of this. This is really just that, mass timber, a question that Robert had asked before. It's a structural material or system. It can be applied to a lot of different construction types within the building code, for anything from low rise now to high rise buildings. Residential and commercial applications are sort of primarily what's been used at the moment, but we're definitely seeing manufacturing facilities, etc., that are really looking into building more sustainable structures and really achieving their sustainability mandates. I think one big high level thing here is that using this structural system really starts to lend itself a similar structural system that can be applied across low-rise and high-rise buildings. You can start to look at panelized systems or hybrid systems, and using that same system for high and low and high-rise buildings. And you start to see the efficiencies of a site that may have low-rise and high-rise buildings, and you can use that same structural system, same craneage, same delivery method. And you really start to see a lot of efficiencies in construction.
Awesome. So now let's just jump real quick, and I know we're probably running tight on time, on just some solutions, some constructed case study examples. So first up is a public library building up here in the Bay Area that was completed back in probably 2016. This was with Fog Studio and Lathrop Construction, about a 20,000 square foot library. Again, seeing a hybrid structural system in that, the lateral systems haven't really caught up to being able to have mass timber lateral systems. So this is just CLT floors and roofs with steel moment frames as the lateral system. So I really like these pictures is in that it shows, these pictures weren't taken on a lunch break, and it really just speaks to the minimum amount of people it takes to erect these buildings. So really hitting home on a point Chelsea made earlier is that it only took about 4 people to kind of erect the CLT for this building. This contractor had never worked with CLT before, but was very open for the challenge. And, the panels went up way quicker than they were originally had forecasted in their schedule. And, we barely made it out to get some final photos of them lifting the last panels in place. So again, we had utilized the CLT as a diaphragm for this building, at least on the roof level. And so that's kind of what you're seeing on the left are these kind of plywood splines that are tying the panels together. We did have a small concrete topping slab on level 2 just to handle the heavy stack loading. But we did get to achieve some pretty fun cantilevers in it, and it's a really beautiful aesthetic in that kind of final product. And the last case study we'll touch on is kind of that North America's at least largest mass timber building that has been built. So this building just opened this year, finally. Had a bit of COVID delays, but it's a very exciting project to kind of have complete now. And it is a large new commercial campus. We did keep 2 of the 5 existing buildings, which you can kind of see those little L-shaped buildings in the corner there, and then kind of infilled in with this low-rise mass timber construction. We were able to permit this type 3B construction. So primarily all of the structure is unrated, which definitely helped with the aesthetic and keep the cost down. This project is a bit unique in that it is a composite concrete and CLT slab, and we made it composite with the concrete so that it could span further. And that is supported by steel wide flange beams and glulam columns. I think a big story of this project was just the sheer volume of timber that needed to be procured at one time back in, I think it was 2017 when we went out for bid. To limit the owner's risk in that is that we at permit had left what type of mass timber the project could be open. So we definitely permitted either like an NLT or CLT with option for anyone to kind of submit a bid for an alternate floor system as long as they met some of the project performance criteria. That definitely meant that our mass timber supplier was brought on board very late. So after we had already submitted for permit, and it did require some rework of some of the connections and the designs of things just to accommodate that. But anyway, yeah, the project ended up going CLT with StructureLam. We did get very competitive bids out of Europe, but I think from a sustainability story and just worry of if we needed a replacement panel and the lead times that the owner selected StructureLam. But at the time that this project alone was 1/3 of their kind of annual production capacity. So it was definitely a large volume of wood required at one time. The contractor decided to erect this building like a steel structure. So you can kind of see on the right photo, all of the glulam columns came out with their steel connectors inside, and they lifted them into place and just kind of, dropped everything on for level 1 and then just went up. That picture on the left is showing a lot of this, the MEP penetrations already CNC routed into the panels, and they all come out on site and yeah, get lifted into place.
Megan, can you answer Carrie's question?
Oh yeah,
quick?
sorry. Yep.
Sorry, I have another question again, going back
Yeah.
to the smaller scale projects. We're
Sure.
really eager to test this out.
Yeah.
If in certain locations, you just can't get a crane all the way out into a certain site. It's just not going to be possible. What do you think is the largest size panel that construction, could use without having to have a crane lift it? So that if you're talking about a house or a small, outbuilt farm out buildings, ranch out buildings, what in a practical sense size panel can people actually manage?
That's a good question. I don't know if I know the answer. I'm sure that and we've done some very small scale projects, but yeah, I was thinking there's got to be some other smaller scale equipment that people can use to lift the panels, and it would be probably limited on their capacity of that. So you could easily get the density of wood and then and back calculate out kind of max weight and panel size that you could lift. But I don't know if anyone else on the call.
Well, Jennifer
Chelsea.
points out that a forklift would be an option in certain situations.
Yeah, I think it would be limited to whatever equipment you can get out there that is able to do any lifting, whether it's scissor lift or some other like a Manitou or some other equipment, whatever is an appropriate lifting mechanism. From that, you could then get a blank panel transported to site, which can then be cut up into smaller sizes, which would be liftable by that equipment. The benefit is that it's pretty simple on site to modify these panels once they turn up. A chainsaw is typically used on construction site to modify these panels.
So in some ways, you'd have to almost start the design of the building based on the assembly. How can you actually install these things and then work backwards from your
correct. Yeah, and quite often it's making the most efficient use out of the press, as well as Megan outlined on the Microsoft project. Is the presses are making a certain size panel. It's going to be most cost effective and from a delivery perspective is to try and structure your structural system around what that panel is able to manufacture, whether it's half size panels or full size panels, because that really starts to create the best cost efficiencies.
And there are a couple manufacturers who do specialize in smaller panels, like Vaughan Timbers is really interested in doing residential, and they have 4-foot wide panels, which are easier to lift into place. And I think Binderholz also has a 4-foot wide option as well. So they're already putting that efficiency for those smaller panels.
Great to know.
Yeah.
Great to know.
And I can also ask, we've done a couple like high-end residences that have been using CLT for their roof. And yeah, I can definitely ping those design teams and see if they had any feedback from the contractor on how they were erecting their panels. Yeah, so I think that's really it. Just really trying to cycle through just some final photos. I mean, I think, being in a mass timber building, you kind of get it and you get what the hype is about and why it's like been gaining so much traction. It does just have a really clean aesthetic. The timber that comes off the truck is kind of your finished product. Like you don't need to paint it or do anything else to the underside of that surface. That is really just your exposed aesthetic. So I think with that, we can turn it over to Jennifer. I think you might have a few things to chat about before we get into the Q&A.
Yeah, thank you. Thank you, Megan, Bevan, and Parisa. That was great. And just for the audience, we have a lot of great questions. So if we go a little bit over the past 1:30, we'll stay on until we get all the questions answered.
Okay, great. Can you hear me okay? Okay, great. I love that last series of questions, Kari, because it really allows me to segue pretty easily into my conversation as a participant. I just first, I want to really thank Libby and Charmaine for putting this together, and Matthew. It's a terrific topic, and I'm really happy to be a part of it, and that the timing worked out perfectly for the start of the semester at USC. And also Megan, Chelsea, Devin, and Parisa for participating at this level. I think that it's a truly unique situation when an educational environment gets to merge with a practical environment, and the joy, of working in those two worlds, for me personally, is why I work in those two worlds. So thank you all. This question, I'm going to show some examples from my company, Office of Mobile Design, as Libby mentioned, founded in 1998. This question that I raise of what Buckminster Fuller, what raises, Madam, do you know the weight of your house, was not something I was ever asked when I was a student, but it's something that I will and forever ask my students. It comes up quite a bit in the kind of work that I do in modular construction. As we all know, modular construction is limited by the height, the length, and the width of something that can move down the road. Sometimes it's picked up by a hand, sometimes it's picked up by a crane, sometimes other forms of movement are needed. Modular constructions come, I wouldn't say it's come a long way, it's come some way since really the 1940s. Typical imagery is from the factories that I work with here in California. They tend to be steel moment frame buildings built side by side. The limits are 12'6" to move something down the road. Maximum width is 16 feet, with a length that's being less important. You can go 60, 80 feet long, but those are the limits that you work with, and then you work from the design back, from the limits back into your design. Transportation and install is varied. I mentioned, depending on the weight and size of the module will determine the scale of the crane or the lift that you need. But in terms of design, there's really no limitations. All of the modular buildings that we do are permitted with the state architect and inspected in the factory, which is a tremendous time savings of probably a third, and a much more efficient and, I would argue, sustainable way of building. Again, about a third less material waste occurs in a more controlled setting like a factory than on site. Here's a couple quick examples of work that Office of Mobile Design has produced over the years. This was one of our first attempts. It was became a show model here in Venice with one continuous sloped shed roof at its highest point with an operable skylight, thinking a lot about green materials early on, bamboo flooring, polycarbonate panels for insulation. And then ultimately, this building moved to this location. This is in Joshua Tree, and it became a fully off-the-grid home for a man who collects homes. And then this is also an example that was done with a group of students at Taliesin in Scottsdale, Arizona, the former architecture school called Taliesin. And it was built with a steel chassis and a hybrid of SIP panels, structurally insulated panels. Again, another fully off-the-grid structure in the desert, and one continuous modular piece. The reason I'm showing some of these ideas is that it's an evolution for me of how I became interested in mass timber. This is what an infill of SIPs looks like in a steel frame. And here's an example of a house that Libby's probably familiar with because she lives in it. That's in Big Bear. That was a SIP panel house built also to be fully off the grid on a very remote and stunning location. as you can see, with a variety of different materials that were sourced locally and installed. That brought me to teaching at USC last semester, where I was asked to teach a studio on mass timber, which I had never worked with before. I was lucky to meet Megan Stringer, who was lecturing with the LA AIA through Holmes, and started to spend more time thinking about the integration of mass timber and modular construction. This is my first attempt, a home that we're working on in Big Bear. Shout out to one of my students that's in this group, Natalie Hubb, who's been working on this project with me in my office. And it's made up of 6 mods, partial site built, and a mass timber roof, as you can see here. So what the mass timber allows me to create is a kind of alpine-esque feel with an exposed Douglas fir finish. The panels are coming from Vaughan, as was mentioned earlier by Chelsea, and everything's pre-channeled, pre-routed for my electrical that's in the cavity of this roof. And here you can see an example of how the modules get laid out in these corners. These small little 3x3 posts are steel frames, and those mods, which in this case is about a 56-foot long module. Oops, the ghost in my machine. And we've kept these mods below 12 feet for the economy of movement. So these are all 11-11, and then they come together on site. It's called set and stitch. So that's the first floor, and this is our second floor plan. And we also have, as you could tell, like one open cavity in the roof, so that there's a clear span within this building. The mods will come without a roof on them, so that you will be able, or the client will be able to enjoy that open space. And the assembly, we expect to take place over the course of probably a week. The modules get set within a day, and then because it's our first attempt, setting the panels on top, we're giving ourselves a week to complete. That's it.
Excellent. Thank you. Those were all great presentations. We've got a number of questions here. I'm going to have Matthew moderate those, and then feel free to raise your hand and ask a question live. We really have not only a fabulous set of panelists, but a fabulous audience as well.
So I'm going to just ask this one from Sally Ann of, the type of adhesive that is typically used. Like, what are the, are there any concerns that people have regarding the type or the sustainability of those adhesives, and any off-gassing concerns that we might have seen with other adhesives being brought up with these ones?
That's a good question. We've gotten that a lot at Woodworks, so I do have some material I can send on that. They are low emissions, low VOCs. There is not any concern of off-gassing. But I think there are still some people who don't like the idea of adhesives, and that's where dowel laminated timber is a great option. But there's not a concern there for emissions.
And Bev and Parisa, have you run into any fire concerns from the adhesive sides, or is that not something that's been something that you have had a problem with?
No, now that the manufacturing standard PRG 320 has been updated to the 2018 version now, which is now being used by all manufacturers providing products, and overseas manufacturers supplying products into the US are using that standard. It has a specific test for addressing adhesive performance. What was an issue in the past of delamination of mass timber elements exposed to thermal degradation. So those have been addressed now, and so essentially we have mass timber performing similar to a sawn lumber piece of material.
And then, Megan, you touched on a little bit the, this allowing to use smaller tree sizes, but has anybody looked into the benefit for how quick you can harvest a young tree versus the replacement rate of those trees into these systems?
I'm sure that there's some data out there, and maybe Chelsea's better to answer. Yeah, maybe I'll throw it to her.
The U.S. Department of Agriculture has a lot of studies on, our forests, how stable they are, rate of replacement, how much wood we are harvesting, and there's actually an incredible visualization I'll put in the chat that kind of visually shows that, how much we are harvesting versus what's out there.
Yeah, and the one cool thing, at least about the CLT, is that we were able to utilize some of the lumber that's been killed by the pine beetles, and so yeah, we tried to get as much of it as we could on the Microsoft project. And so if you ever get to go there, you can kind of look up and see some of the, and Chelsea, you had it in your picture of the CLT. It kind of has like a bluish gray tint to the wood, and you can see that, and doesn't affect the structural properties, but just another great example of how we can utilize something that would have kind of been just like a waste product, but being able to use that structurally.
That's amazing. Also, like in the Oregon producers, I know Ferris and DR Johnson both have talked about how all the wood they're using right now, are like 60 to 90% of it, is post-fire salvage wood, because after a fire, the burnt trees need to be used within a couple of years. Otherwise, they are taken by beetles and insects. So they're really quickly using that and harvesting it. So that's a really interesting point, I thought, as well.
Yeah, that's great. I had a kind of similar question along those lines. If architects increase the use of mass timber, is the supply end ready for such an increase?
The suppliers definitely have additional capacity, and there isn't a concern right now with over harvesting in our country.
Was there any others, Matthew?
I see one question from Robert on the Microsoft detailing that I was going to type out, but I can answer live. So I think Robert's question was just getting at the detailing and concerns over shop drawings. So I can kind of talk to you about that process a little bit. So for the timber detailing, we as the structural engineer of record took on the design. So all of those nested steel connectors that you saw on the slides, that was all designed by us. We did get Bevan and Priest involved from a fire perspective, and we had a couple locations where they did need a 1 hour rated corridor, and they didn't want to have to cover everything with gyp. So we got them involved to kind of prove that the structure could char and we could handle it and provide the 1 hour rating. Anyway, so we did do all the design and detailing of the steel details for the timber. And I think your question is around like shop drawings and kind of that, so it was pretty unique in that. So we did have a main steel sub on the job that was providing all of the main wide flange beams, but for the actual steel connectors that were within the column, we had Structureland provide those. So they worked with a local steel supplier up in Canada, and they supplied all that within the glulam columns that they also supplied. And so all of that came out fast together and came to site as one piece. We did get into some challenges in that it was in Canada, and needing to make sure that they're following the welding procedures that are within our local jurisdiction. So there was a little bit of that. We also had to talk a little bit about special inspection of how they would get the mass timber special inspected up in the shop in Canada. So that was kind of just some fun conversations that we had there. we did have to take into consideration in some of the detailing of kind of who owns what. So knowing that Structurland was providing the steel that was coming out connected to the columns, we did have to redetail in some cases, just some atypical connections, or where we were connecting like a curtain wall girt, for example, just redetailing it to accommodate that, you know, the column steel is coming from one person and the main structural steel is coming from another, and needing to be able to, accommodate that from a fabrication standpoint. So the shop drawings, the Structurlam did do all of the shop drawings for those steel connectors and all of the mass timber, and then that was reviewed by engineer and architect, so a very typical process. We have been, as structural engineer of record, been getting involved a bit in shop drawing, producing shop drawings for our mass timber projects. So we have kind of taken that on for some projects. It's not like a line of design services that I think we want to get into or expand, but we're definitely able and capable of doing that. And that really is just, you know, laying out the panels. And we've been asked a lot of times on projects to do and take on that work. If they don't have a supplier on board, for example, and the contractor wants to really understand like how many panels they're going to have to lift and so that they can start to lay out their process. So it really just kind of depends. But yeah, any type of these mass timber projects where you're having the connections are always really critical to the project, because usually they're really exposed, they're seen, they're visible. And so just, yeah, wanting to pay close attention and making sure that you're coordinating with all the appropriate parties is going to be key to you know, the success of it.
Great. I had a question. Sally Ann had a question, but I have a similar one. What's the R ratings for the panels, let's say CLT as an exterior skin, and how do you integrate insulation?
Yeah, so the R value is about 1.25 per inch for mass timber, which is pretty good. And there are some example details for roof and walls in the CLT design manual. There's a section on enclosures, and it's, you know, on a roof, you put the insulation on top, and on the wall, it's on the outside face. But yeah, there's some examples for that. Also, RDH is a local enveloping engineer, and they have some great resources, most of them free, and provide detailing for that as well.
That's great.
And Megan, I have just a question with coordinating different projects. Have you run into challenges with the coordinating the foundations and the concrete contractor with getting their tolerances to an acceptable level where you can build such a tight tolerance of a pre-manufactured element on top of that? Because most foundation contractors are pretty used to having slop in their system, and then all of a sudden you're like, no, I need this foundation within a 1/16 of an inch, and how that gets rectified, I guess, in the field.
Yeah, we had a lot of talks on that, not necessarily as much in the foundations for the project, but we had concrete shear walls. And so, you know, those walls were off in some cases up to like almost 3 inches at the worst. And so being able to accommodate that in your detailing, because your mass timber elements are going to be exact, you know, and not vary at all. Whereas, you know, steel has a little bit bigger tolerance, and then concrete could be like a bit all over the place. So yeah, you do need to accommodate that in your detailing. For the foundations, I guess it's really just being able to set your kind of your base plates or your wall, like, yeah, just being able to get your detailing at that foundation interface to be able to accommodate that is probably the best way that you should take it on as the designer to tackle that, knowing that the contractor is likely going to be a little off, but it is a challenge and something that you need to consider.
I had one other question that in terms of carbon calculator, you know, a lot of projects now are having that are trying to get certification are requiring knowing what their carbon offsets are. Megan, does Homes calculate that, or can you?
Yeah, that's a great question. I was gonna see if I had a slide real quick I could pull up, but yeah. So, and Chelsea and I are on some committees together looking at structural sustainability and embodied carbon, and really getting into accounting or carbon accounting for your projects and getting into life cycle assessment. And so that is definitely something all structural engineers should be doing and able to provide for your projects. And we've been doing, and maybe I'll steal the screen again and just share. We've been doing Lca case studies on a lot of our projects, and trying to finalize actually the Lca for the Microsoft project, which and looking at the comparison between the impact of the mass timber office portion versus the existing buildings that we've saved. And so oh crap, hold on, I might have to, one sec, trying to oh, maybe I don't have it. Oh no, I have it right here. Screen real quick. I think this should work. So this is just a very typical, this was just a schematic level study where we were looking at a mass timber office building, whether it was a steel mass timber hybrid or comparing that to, a steel framed structure with concrete or metal deck or a concrete building. And looking at the correlation between building weight and seismic base shear. I think it's been said a lot is that these mass timber buildings weigh less than their steel and concrete counterparts. So that's what we were seeing. And so we have less seismic mass, less building weight, less foundations, and that really translates over into the kind of embodied carbon side of things. So looking at global warming potential, you can kind of see that the orange is the steel mass timber hybrid, and we're about like a third of the impact of the concrete building. So these are just, very simple studies that we do a lot of times early on projects when we're just comparing different options. And then once an option is selected, the spirit of LCA is to then work within that system selected to track your design decisions throughout the project and show reductions over time.
Well, I think Buckminster Fuller would be greatly impressed, and you could answer his question as to how much the building weighs. So that's fabulous. Well, we're at our 1:30 mark, and this has been really great. Thank you, all of you, for being here. For those participating, we will get the slide decks out to you. So Megan and Chelsea, if you can share those with us and send them to me, and I'll make sure to get them to Charmaine, and we'll distribute those. And we'll have this recording up on our website in a week or two. So thank you again for being here, and have a great rest of your Friday.